Okay, hi everyone. So today I'm going to help you to revise on chapter 5, particularly magnetic field strength and magnetic force. So as you all have known, chapter 5 is not examinable in paper 2, but you need to know the basic of it in paper 1. So my focus today is to help you to revise on how to find the magnitude and direction of magnetic field strength and magnetic force. So let us begin with magnetic field strength. As you all have known, magnetic field strength can be produced in a current carrying conductor. And there are three types of current carrying conductor that we're going to study today in your syllabus. The first one is long straight conductor. The second one is circular coil. And the third one is solenoid. Okay? So let us start with the first one, magnetic field strength by long straight conductor. So how can we determine the magnitude for the magnetic field strength produced by the straight conductor? So this is the formula that you should use. B equals to mu naught I over 2 pi r, where mu naught is the permittivity, I is the current that passes through the conductor, and r is the distance between the point where the magnetic field strength you want to find is from the conductor. Okay? So, and then what about the direction of the magnetic field strength produced by a straight conductor? So, there is only one way to do it. Okay? There's only one way to determine the direction, which is right hand grip rule. Okay, can you see this? Right hand grip rule. Okay, so how do you use right hand grip rule to determine the direction of the magnetic field strength? So let's say this scenario. I have a conductor where the current is flowing upward. Okay, so by using right hand grip rule, okay, this is your right hand grip rule. Okay, and then this is your conductor where the current is flowing upward. Okay, so what you can do here is take your right hand, grip your conductor, okay, where your thumb points in the direction of the current, which is in this case upward. Okay, and see the direction of the rest of your fingers. Where does the rest of your fingers curl? So if you can see from top view, it is curling anti-clockwise. Okay, just like in this diagram here. Okay, so you can say that the magnetic field strength flows anti-clockwise from top view. Okay, but what about from front view? So from front view, we can see that on the left side of the conductor, the magnetic field is flowing out of the page, like this. Okay, but on the right side, we can see that the magnetic field is flowing into the page. So you can use a dot and a cross to represent the direction of magnetic field from front view. Okay? Are you all clear on this? Okay. Oh, sorry. Okay, what about this? Still a straight conductor, but now the conductor is lying horizontal like this. Okay? So where is the direction of the current flow? It's to the right. Okay? So same thing. Use your right hand. Grip the conductor. Okay? Use your right hand. Grip the conductor. Okay? In a way that your thumb in a way that your thumb points to the right. Okay? In the way that your thumb points to the right. And then can you see that how your forefinger curl as you grip the conductor? So that is the direction of your magnetic field strength. Okay? And as you also can see, from front view, the magnetic field comes out of the page, above the conductor. Okay? And below the conductor, we can see that the magnetic field enters the page. Right? From front view. Okay? So, yeah, sorry for the bad orientation because the camera is in front, so I can't really like grip it nicely. Okay? But I hope that you can see it. Alright? So this is the direction. Okay? Out of the page, above the conductor, and into the page below the conductor by using your right hand grip rule. Okay? Okay, next is a circular coil. So how do you find the magnetic field strength produced by circular coil? So this is the magnitude. Okay? So this is the formula that you need to use to find the magnitude, which is mu naught I over 2R. So all these formulas are given to you in your list of formulae. So don't worry about it. Don't worry about memorizing it. But what you must know is which formula to use for which conductor. Okay? Okay, so what about the direction? Again, you use your right hand grip rule. Right hand grip rule. Okay, to determine the direction of your magnetic field strength. Okay, so let's say I have a circular coil like this. Okay, where the current flows here and goes out from in this way. Okay, so how do you determine the direction of the circular coil? Again, you use your right hand grip rule. Use your right hand, okay, to grip the conductor. Okay, and your thumb must point in the direction of your current flow. Okay, so just like in this case, so when the conductor is flowing in this way, in this part of the coil, you just grip it. Okay, you just grip it, and then you can see that the magnetic field flows up. Right, can you see that your magnetic field flows up? Okay, your magnetic fields flow up. Okay, yeah. And what about in this direction here? So you can see that your current is flowing into the page. Okay, and then when you grip it using your right hand grip rule, then your current flows into the page in the same direction as the current. Can you see that your forefingers are pointing up as well? So that's the direction of your magnetic field, pointing up. What about here? This one here. So you can see that your current flow is to the left. And same thing. Use your right hand, grip it. Okay? And then your thumb must follow the direction of your current. So can you see that inside the coil, your magnetic field is pointing up as well. Inside the coil. Okay? So inside the coil here, you can see that at any point along the coil, your magnetic field is always pointing up. So if I want to draw my magnetic field lines, so this is what it looked like. Okay? The magnetic fields are all pointing up inside the coil. So it is as if this circular coil where current is passing through it act as a temporary magnet, okay, with two poles. a north pole and a south pole. So where is the north pole here? This is the north pole where all the magnetic field lines comes out from it. Okay? And this is the south pole where all the magnetic field lines enter into the pole. Okay? Right. So the next one is solenoid. Magnetic field strength produced by solenoid. So how to find the magnitude of the magnetic field strength at the center of the solenoid? So this is the formula. B equals to mu naught N I. And what is this N? N is the number of turns per unit length. Please remember this. N, small n, is the number of turns per unit length. Okay? So, but at the end of the solenoid, the magnetic field strength decreases to half of that at the center. So, the magnetic field strength becomes half mu naught N I. So please remember this. It might come out in the exam paper 1. Okay? Okay, now the direction of the magnetic field strength produced by solenoid. Same thing. Use your right hand grip rule to determine the direction. Okay? So here's an example. So you can see here, you have, this is solenoids, okay, with 1, 2, 3, 4, 5 turns. So can you see the direction of the current flow inside the solenoid? Can you see this red arrow here? So the current is flowing out of this point here and into this point here. Okay? So let's take a look at this point where the current is flowing out of the page. Okay? So how do you use the right hand grip rule in this case? So again, use your right hand grip rule. But now, your current is flowing out of the page at this point here. Okay, your current is flowing out of the page at this point, and you grip it using your right hand. Okay, and then your thumb is pointing in the direction of the current flow, which is out of the page. So, what about the rest of your finger? How is it gripping? So it is gripping in the direction of anti-clockwise. So that is the direction of your magnetic field strength. Okay, anti-clockwise. What about this point here? So current flows out of this point into this point. So now your current is flowing into the page. Okay, now your current is flowing into the page. So how do you use your right hand grip rule to determine the direction of your magnetic field strength? So use your right hand, okay, grip it in a way where your thumb is pointing into the page as well. So can you see how the rest of your 4 fingers grip the conductor? It is gripping in a direction which is clockwise. Clockwise. Okay? So that is why the magnetic field strength here is clockwise. So same thing goes to this point here and all these points. Okay? And overall, you can see that the magnetic field here inside the solenoid, okay, are all pointing in one direction. Inside the solenoid, they are all pointing in one direction, which is to the right. Okay, which is to the right. Okay, so you can see that the whole solenoid now has become a temporary magnet with 2 poles, a north pole and a south pole. So where is the north pole? It is here, where all the magnetic field lines comes out. Okay? And the south pole is here, where all the magnetic field lines enter. Okay? So this is how we find the magnitude and direction of magnetic field strength produced by current carrying conductor. The magnitude is found by the respective formulas that you need to know, okay? And the direction is found by right hand grip rule. Please remember this. Okay, next is the magnetic force. So magnetic force can be produced in two conditions. The first one is moving charges. The second one is current carrying conductor. When a moving charge enters the magnetic field, it will experience magnetic force. When a current carrying conductor is inside a magnetic field, it will experience magnetic force. Okay, so first we're going to determine the magnitude of magnetic force and its direction in moving charges. So what is the magnitude? How do you find the magnitude of moving charges? The magnetic force experienced by moving charges in a magnetic field. So this is the formula. F equals to Q V cross B. So it is very important to know this vector product. It is V cross B. And it will produce, this force is the product of this vector, okay, multiplication. So what about the direction? Use right hand vector rule. Use right hand vector rule, okay? So example here, I have a positive charge, and this positive charge is moving in this direction with a velocity v, okay? So, and it is moving inside the magnetic field. What's the direction of the magnetic field? This is the direction of the magnetic field. So, meaning it will experience magnetic force. So, what is the direction of the magnetic force? Use your right hand vector rule. Okay? Your right hand vector rule. So, how do we use right hand vector rule? Remember this. V cross B will produce the F. Okay? So, first, you have to point your finger, your four fingers, in the direction of your first vector, which is velocity. So what's the direction of velocity in this case? It's to the right, to the left. So I point it in the direction left. And cross what? This vector V have to cross B. What's the direction of B? B is in this direction, okay? Which is into the page actually, right? So you have to align, arrange, turn your palm, okay? So that your four fingers can curl, okay? Your four fingers can cross from V to B into the page. So what's the direction of your product? Which is your force? It is represented by your thumb pointing downward. So your force is downward. V cross B, force downward. Okay? Okay, next is this. Okay, another positive charge. Okay, but this positive charge is moving velocity in this direction, and it is inside the magnetic field, which is in this direction. Okay, so what's the direction of the magnetic force? Again, use your right hand vector rule. Okay, first point the direction of velocity, which is, okay, out here, okay, outside, out of the page, and then cross B. Where is your B? B is to the right. So how do you curl your four fingers to the right? So you have to twist and turn, okay, your fingers so that you can cross from V to B, from V to B. So what's the direction of your force? Upward. V, B, force upward. Okay? So this is for positive charge. What about for negative charge? So for negative charge, it's very easy. Use the same right hand rule. Okay, use the same right hand rule. So let's say this is a negative charge. So use the same right hand rule. Okay, V cross B, force upward. But because it's a negative charge, you just reverse your force, the direction of force in the opposite direction, which is downward. So for negative charge, the direction of magnetic force produced is downward. Okay? Okay, try these 4 examples here. Okay, let's try this first one here. So this is a positive charge moving in this direction. Okay, magnetic field is out of the page. Okay, so again, I use my right hand. First, my 4 fingers have to point in the direction of your velocity, v. So where's v? Here. This is your v. Okay? And what's the direction of the magnetic field? You have to cross the magnetic field. It's out of the page. So, v cross b out of the page. V cross b out of the page. So your force is downward. Okay, what about this one here? Again, same thing, a positive charge. Again, use your right hand rule. Point in the direction of velocity. Point in the direction of velocity. Okay, and then magnetic field is into the page. You have to cross into the page. How do I cross into the page? So I have to turn my finger. Okay, so that my velocity to the right can be crossed into the page. Right, velocity, cross v. Velocity, cross v. So my force is upward. Okay, so what about this one here? Okay, it's the same thing. Velocity there, cross magnetic field into the page. My force is upward. But because it's a negative charge, now my force become downward. Okay, what about this one here? It's a negative charge. Okay, so my velocity there, but my magnetic field out of the page. So velocity cross magnetic field out of the page, force is downward. Okay, but because it's a negative charge, I have to reverse it upward. Okay. Okay, what about magnetic force experienced by a current carrying conductor in a magnetic field? So the magnitude to find the magnetic force for current carrying conductor is I L cross B. So the direction is determined by right hand vector rule also. Right hand vector rule also. Okay, so let's look at this condition here, this situation here. So this is my conductor, my current carrying conductor. The direction of current is downward. Okay, and it is inside a magnetic field which is out of the page. So remember this formula here. The vector product is L cross B. L cross B, and this is the force is the product. So what's the direction of L? It always follows the direction of your current I. Okay, so let's use right hand vector rule to determine the direction. So this is your right hand, and then your 4 fingers must first point in the direction of the first vector, okay, which is L. And we know that the direction of L follows the direction of your current I. So in this case, what's the direction of your current I? Downwards. So you can point, 4 fingers, point downwards. And then cross B. Where's your B? Out of the page. So I, L, cross B, out of the page. L cross B out of the page, your force is to the left. Okay. Next, what about this? Right hand. So my 4 fingers points in the direction of I. Okay, which is upward. Okay, I pointing upward. Okay, cross B. Where is my B? My B is to the right. So how do I point it to the right? So I have to turn my finger to the right. Okay, I have to turn my finger to. Okay, so I cross B. So I is pointing upward. Okay, but my magnetic field is to the right. So I have to turn my finger to the right so that I can cross B. I cross B. My force is into the pitch. Okay. Okay, next. Next. So I have current to the right also. Current to the right. Okay. But my magnetic field is into the page. So how do I turn my finger so that my finger can cross from I to B? So I have to twist my finger this way so that I can I cross B, force upward. I cross B, my force is upward. Okay, what about this? I cross So what about this? Is it I cross B, my force upward, or I cross B, my force downward? This is a question for you to think. Is it possible for I crossing B here in this case? Why? Yes, and why not? Okay, so this is for you to think about. Think about it. All right? And then if you have any questions regarding this, let me know. Okay? I'm free to take on any answers that you have or any questions that you have. Okay? Okay, next. What about this case? I is into the page. B is upward. Okay? So again, use my right hand rule. So my four fingers have to point the direction of I, which is into the page. And then what about my magnetic field? Upward. So I have to turn my finger so that I cross B. I cross B. But what's the direction of my force? To the right. Okay? Okay, what about this? I cross B. Right hand vector rule. I out of the page. Cross B. How to cross B? So I have to turn my finger. Become like this. So I out of the page, cross B. I cross B. So my force is downward. Okay, what about this? So you are given force, okay, experienced by the current carrying conductor inside a magnetic field which is pointing out of the page. So what is the direction of current? So it is like a reverse process, okay? So first of all, take out your right hand as well, right hand vector rule, okay? So now you know the product is pointing up, okay? So, and then you know that the thumb is the direction of your product, which is force. So force is pointing up, okay? So this force is a product of vector L and cross B, L cross B. But you don't know the direction of L, but you know the direction of magnetic field, which is out of the page. Okay, so something something, I don't know, okay, but it's crossing B, right? So how do I cross B, which is out of the page? It means my current have to point in the left direction. Okay, my current to point to the left so that I can cross B, which is out of page, to produce a force upward. So the current is to the left. Okay, what about this one here? Again, fixed. You know that the product force is upward, so your thumb must point upwards. Okay, And then you know that your magnetic field is to the left. Okay? Your magnetic field is to the left. But I don't know what's the direction of my current. So how can I cross to the left with my thumb pointing upwards? So it must be right. Okay? So it must be when the current is out of the page. Only then you can point it to the right. I cross B, force upward. So current is out of the page. Okay, what about the last one here? Again, use your right hand, vector rule, thumb points in the direction of the force, and your magnetic field is into the page. So how do I cross from I to B into the page? So meaning, in order for me to cross into the page, my current has to point upward. Current upward, cross B into the page, force to the left. Okay. Alright, that's all from me. All the best in PSPM2. I hope this video is helpful to you, especially in determining the direction of magnetic field, strength, and magnetic force using right hand grip rule and right hand vector rule. Okay, so all the best in PSPM2, and see you again after this MCO. Bye.